Okay, good afternoon. We are back with another practical. We're going to be looking at the reaction of metals with strong acid. Okay, now this is another way of looking at the reactivities of metals. If you're really interested in it, we've got a longer feature-length video where we talk about it in much more depth. But very quickly, hazard, strong acid is corrosive. Risk, I could get acid on my hands when pouring it into my test tubes. Control measure, I could wear gloves. If I was worried about getting it in my eyes, I could use goggles. But the one I'm going to use today is using a dropping pipette. Now, in each of these test tubes, I have got 4 metals. I've got copper, iron, zinc, and magnesium. For those of you which love your reactivity, you know that copper is the least reactive and that magnesium is the most. And I've put them in order actually, so I've got least reactive to most reactive. Now, I'm going to pipette roughly the same amount of strong acid into each test tube. We're then going to make some observations which will show their reactivity. What I'm looking for is that whenever a metal reacts with an acid, hydrogen gas is produced. So my rate of reaction, my reactivity, can be gauged by simply looking at the amount of bubbles which are being produced. So in each of these acid in, and then each one a flick to get them started, and then we'll be able to look at some observations. Okay, I'm going to leave that while I tidy up that. Reaction should be starting. First thing you will notice is that magnesium has bubbled almost straight away and it is fizzing. Okay, so I've got that happening. Whereas copper, down the other side, copper just looks like he's having a bit of a rest really. Nothing is happening at all. So we've got that there. And then in the middle, we'll see that there are slight bubbles for zinc. I hope you'll be able to see that. And finally, some iron. Not a lot is happening. So what we'll do is we'll pause the video now and we'll come back to it when we have some results.
Okay, so Mr. Mulroy has now become Miss Lahan.
Right, so just looking at the results, okay, we've left it for about 5 or so minutes just to see what happens. Magnesium, I know it's quite hard for you to see, but it's giving off the biggest reaction. You can see loads of big bubbles, quite a lot of fizzing of hydrogen gas. So if we were to put a lit splint in here right now, should get a squeaky pop, okay? Next then, zinc is the next reactive, okay, so it is giving off bubbles, but not as frequently as the magnesium. Iron filings then, okay, it's gone a bit of a funny colour, but that's just to do with what is on the iron filings. There are some bubbles, but not to the extreme of the zinc and the magnesium. And then copper, after about 5 minutes, still nothing happens, okay? So it doesn't really have a reaction with acid. We could then use this to rank metals in order of reactivity. A couple of inaccuracies, well, you can see here we've used iron filings and magnesium strips. I was going to say zinc then. Magnesium strips, okay. Magnesium strips obviously have a larger surface area, so they should take longer to react than iron filings because they'll have a smaller surface area to be able to react.
Really quickly, I'm going to interject because I feel like it all got a little bit confusing. So this is a smaller surface area, say a large magnesium strip, and then this is a larger surface area, say the iron filings. So there is more space for the acid to collide and react over here compared to here. This has only got 4 corners or 4 sides, whereas this has got 4 times by 6. So small surface area, less places for the particles to collide. Large surface area, more spaces for particles.
Also, another inaccuracy is that we're kind of just looking at them and making observations. So another thing to be able to do would actually be able to collect the hydrogen gas given off, and that would give us a more accurate result as to which one was the most reactive.